Hello everyone, welcome to course study on solid mechanics. In today's lecture again we will discuss the numerical based on the generalized Hooke's law. Now we have the problem statement as below. A plate of 2 by 2 by 0.02 meter is subjected to stresses sigma x is equal to 100 MPa tensile and sigma y is equal to 50 MPa compressive in the plane of the plate. The modulus of elasticity of the plate is 200 GPa and Poisson's ratio mu is equal to 0.25. Calculate the volume of the plate. Now from the given numerical we have to find out the value of change in volume of the plate under the action of stresses along x direction and stresses along y direction. Now we have a plate of size 2 meter by 2 meter by 0.02 meter, means the length of the plate is 2 meter, the width of the plate is also 2 meter and its thickness is 0.02 meter. Means it's a two-dimensional plate because its length and width is greater than its thickness, therefore we can consider it as a two-dimensional plate. This particular plate is subjected to a stress of sigma x, means it is the value of stress along x direction of the plate and that value is 100 MPa tensile. 100 MPa tensile means it is acting away from the plate. So it is tensile in nature, we can consider it as a positive one. And sigma y is equal to 50 MPa compressive. The value of stress along y direction of the plate is 50 MPa compressive in nature. So that particular stress will try to compress the body. From the data we have the modulus of elasticity of the plate equal to 200 GPa. And Poisson's ratio mu is equal to 0.25. We have to find out the volume of the plate, means change in volume of the plate. Now how to find out that change in volume of the plate? We have the concept of strain. We have the concept of volumetric strain. Epsilon V is equal to change in volume upon original volume. From this we have to find out the value of delta V. To find out the value of delta V we must know the value of epsilon V. Epsilon V is nothing but it's a volumetric strain. We know the value of V which is already given in the numerical, only we have to find out the value of epsilon V. Now the strain in volumetric strain is given by, it is the strain in x direction plus strain in y direction plus strain in z direction. The summation of all the strain along x, y and the z direction is nothing but the volumetric strain. To find out the value of volumetric strain we will require to find out the value of epsilon x, epsilon y and epsilon z by using the concept of generalized Hooke's law. Now the value of epsilon x by using generalized Hooke's law can be found out by using this equation, means it's an expression of the strain along x direction in term of stresses along x, y and z direction. But we have already discussed the generalized Hooke's law in the previous videos also, or in the previous lectures also. Therefore we have epsilon x is equal to 1 upon e into bracket sigma x minus mu into sigma y minus mu into sigma z. Therefore if I put the value of e and sigma x, sigma y and sigma z, I have 112.5 upon e. Now the value of e, it is 200 GPa, that value we are going to put. The value of sigma x which is given in the numerical is, it is 100 MPa which is tensile in nature, therefore this value of sigma x is 100 MPa which is positive one, because we have considered tensile stress or tensile force as a positive one and the compressive force as a negative one. Therefore, we have sigma x is equal to 100 MPa. The value of mu which is given in the numerical is 0.25 into sigma y is 50 MPa, which is compressive in nature. Means it has a minus sign. Therefore, we have the equation 1 upon E into 100 minus 0.25 into minus 50. And the value of sigma z is 0 because no value of sigma z is given in the numerical because it's a two-dimensional problem. Therefore, this value of sigma z is 0. After putting all the values of sigma x, mu and sigma y, I have strain along x direction which is equal to 112.5 upon E. Now we will find out the value of strain along y direction in the same manner by using generalized Hooke's law. After putting the value of sigma x and sigma y and mu in the value of strain along y direction, I have strain in y direction is equal to minus 75 upon E. Now we have strain along z direction also in the same manner, minus 12.5 upon E. Remember that even though the value of sigma z it is not given in the numerical, but we have the value of strain along x, y and z direction. It's a superimpose or the combined effect of the stresses. Now as we know that volumetric strain is the summation of epsilon x, epsilon y and epsilon z, and that we have already found out by using generalized Hooke's law. After putting the value of epsilon x, epsilon y and epsilon z in the value of epsilon v, I have the final value of epsilon v which is equal to 1.25 into 10 raised to minus 4. Remember that this is the value of volumetric strain in the material. Now once you know the value of volumetric strain, we can easily find out the value of change in volume which is equal to original volume into volumetric strain. And the original volume, that value it is already given in the numerical. After putting the value of epsilon v and v, I have the change in volume which is equal to 10 raised to 4 mm cube. As it is a positive sign, means it indicates that there will be the increment into its volume under the action of given stresses and for a given value of modulus of elasticity and the Poisson's ratio. As we have the positive sign, it means that it is an increment into its volume. We will stop here. We will again discuss the numerical based on the generalized Hooke's law. Thank you.